So we are going to discuss about objective problems of what do you know? Yeah, dual nature of matter and radiation. Okay. Yes. Here it is opening, Nana. Wait. Yes. See here questions. Question number 1. Yes, let us start. So given that the energy of photon of visible light with maximum wavelength is what? Okay, they are saying that energy of photon of visible light with maximum wavelength. See, for example, here see here one there is one plate. On this plate, wavelength of light is falling. Okay, wavelength of light is falling means nothing but photons are falling. Okay, and they are saying that this light is of visible light. Visible light. Clear? And we know visible light wavelength range 4000 angstrom to 4800 angstrom. 7800 angstrom. Okay, yeah. So maximum wavelength will be 7800 angstrom nano. Clear? Yeah. So they're asking energy of photon. We know energy of photon E can be written as hc by lambda. Yes, in first year also we have studied, and second year photoelectric effect also we have discussed this point. Clear? So here what is h? H is a Planck's constant. 6.62 into 10 to the power of minus 34 joule second. Joule second. What is c? C is the velocity of light. 3 into 10 to the power of 8 meter per second. And wavelength we should keep in unit of meter. These are things. Okay. So every time these calculations h and c divided by lambda becomes very difficult task. So that's why what we will do is we will calculate this total value first only. First only we will calculate this total value. Okay. H and c values we will calculate and we will keep this value. Okay. And the value for that is energy value is, remember this already I have explained you while explaining this chapter. It can be written as 12,400 divided by lambda. This lambda value is to be taken in angstrom, in electron volt. Energy value comes out to be in electron volt, not in joules. Or else it can also be written as 1240 electron volt when wavelength is taken in nanometers. Okay, na? Clear? What is, students? Yes. So 7800. Yeah. See here now. Lambda value maximum 7800 angstrom. So we need to use this angstrom unit. So we need to use this formula. That is 12,400 electron volt upon lambda value in angstrom how much? 7800. Yes, two zeros cancel. 124 by 78. Just now I have done that calculation. It will come out to be 1.58 electron volt. It is approximately equal to 1.6 electron volt. Yes, option 2 is the perfect answer. Understood? So for doing this, you need to remember this. This is not given in question. They said that visible light maximum wavelength they are giving. Maximum wavelength of visible light how much? 7800 angstrom. You need to remember this. Okay, got it, students? Next, question number 2. What they have given? What is the momentum of photon having frequency? They have given the frequency Frequency is 1.5 into 10 to the power of 13 hertz. Frequency they have given. Now by using this frequency, you need to find momentum of photon. Do you know momentum of photon formula? P is equal to h by lambda. Yes. Clear? Okay, yeah. So we know lambda, but they have given frequency. Then how to do this? Yeah, we know one more relation, that C is equal to F lambda. Clear? Yes. That implies, then what is F nana? F will be equal to, sorry, what is lambda nana? Lambda value what nana? Lambda value is C by F. Substitute here, H divided by C by F. Correct? Yes. Lambda is equal to C by F, no? Yes, lambda is equal to C. F this side. It will become, comes in denominator. So it will become HF by C. Yes. So momentum is equal to HF by C. HF by C. H value HF by C. H value is 6.62 into 10 to the power of minus 34, and frequency is given 1.5 into 10 to the power of 13 divided by C value we know 3 into 10 to the power of 8. Correct? Yes. 10 to the power of 8 cancel with 10 to the power of 13. How much you will get? 13 minus 8. How much, Rana? 5. Correct? Yes. 10 to the power of 5 will be there here. And 3 divides with 15, 0.5 times. Correct? Yes. So your momentum comes out to be 6.62 into 0.5 into 10 to the power of minus 34 plus 5 is minus 29. Correct? Yes. Minus 29 plus. Got it? Okay. So multiply this 6.62 into 0.5. You will get 5 is 5 2s are 10. 1 will be there, the remainder. 6 5s are 30. Remainder 1 means 31 it will become. Here remainder is 3. Next 5 6 are 30 plus 3, 33. Okay, no remainder now. How many, after how many digits point is there? 1 2 3. After 3 digits point 1 2 3. Yes. Into 10 to the power of minus 29. Yeah. So it is 3.3. 3.31 or 3.3 into 10 to the power of minus 29. Momentum unit is kg meter per second. So this is the answer. Option where is there? Yeah, 3.3 is there, and 10 to the power of minus 29 also is there. Yes, perfect answer. Option 1 is right answer. Simple calculations now. And JEE students, they may ask you this type of questions for numerical problems, integer questions. Okay, in terms of significant figures, they will ask you. Remember, this type of questions they may ask you for integer type questions. JEE students. Okay, na? Clear? Okay. Next, question number 2 is over. Next, let us go to question number 3. Question number 3. What they have given? See there, they have given that the strength of photoelectric current is directly proportional to. Yes, it is a direct oral question. Strength of photoelectric current is directly proportional to what? Photoelectric current. This law of photoelectric effect, some laws are there. First law is what? It is a spontaneous process. It is a spontaneous process. It is a spontaneous process. Photoelectric effect is a spontaneous process. Okay. As soon as light falls on that, photoelectrons will eject out. Okay. Second law is what? Photoelectric current is directly proportional to intensity of incident light and independent of frequency. These are the laws, very important laws for your board exam. Very important laws, these they will ask you. And third law is The kinetic energy of photoelectrons emitted is directly proportional to frequency of incident light, but independent of intensity of light. Clear? Yes, these are the laws, very important laws you need to remember. Okay, so from this, strength of photoelectric current depends upon intensity independent of frequency. Yes, proportional to frequency of incident light, wrong. Intensity of incident light, yes. Angle of incident radiation, wrong. Distance between anode and cathode, wrong. So option 2 is right answer. So for answering this type of questions, you need to know clear-cut information. So when you know this, when you study total thing, when total concepts are there in your mind, then only you can answer this type of questions. Here, next question number 4. Question number 4, see what they have given. Question number 4 is question number 4, Nana? Yeah. So question number 4, they are asking that when light is incident on a surface, photoelectrons are emitted. Yes, we know this. For the photoelectrons, for these photoelectrons, first thing, value of kinetic energy is small for all. No, we can't say this. Okay, next, maximum kinetic energy does not depend upon wavelength of incident light. No, wrong it is. Next, value of kinetic energy is equal to or less than maximum kinetic energy. Yes, it is correct answer. See, according to Einstein photoelectric equation, the kinetic energy of photoelectrons emitted will be equal to incident energy minus work function. Okay, yeah. First statement they have given that when light is incident on a surface, the photoelectrons are emitted. For photoelectrons, value of kinetic energy is same for all. So this kinetic energy, we can't say that it is same for all because it depends upon energy of incident light and wavelength work function. Next, maximum kinetic energy does not depends upon wavelength of light. No, this energy is equal to hc by lambda. We can write no. Yes, minus work function. Yes, it depends upon the wavelength of light. Yes, it depends, but they are given that does not depend, so it is wrong. Next, value of kinetic energy is equal or less than maximum kinetic energy. Yes. So if this work function is 0, it will be equal. If it is some value, then it will be less. So option 3 is right answer. None of the above is also wrong. I hope you understand it very clearly. Conceptual question need to be clear. Next, question number 5. When light falls on photosensitive surface, okay, electrons are emitted from the surface. Okay, good. Electrons will emit. The kinetic energy of these electrons does not depend on what they're asking. See, kinetic energy of photoelectrons depends upon frequency of incident light, and frequency depends upon wavelength. And this kinetic energy equation, just now I have said that energy minus work function. This work function depends upon nature of the material, type of the material. Means this kinetic energy depends upon frequency, wavelength and material used. But only the thing is, kinetic energy is independent of what? Intensity of light. We have studied this is law of photoelectric effect. Yes. So this is your answer. Does not depends upon the argument. So it does not depends upon intensity of light. Got it, students? Understanding now clearly? Next, question number 5 is over. Next, question number 6. Let us go to question number 6. Yeah. Here, see, they have given, I'll maximize this. They have given a work function of a substance is 4 electron volt. Okay. Work function of a substance is 4 electron volt. Okay, good. Work function I write here. I'll mention. Work function is 4 electron volt. Okay. What is work function, Anna? Work function means what? Important question for your board exam. Work function is what? Work function is the minimum amount of energy required to eject an electron from a metal surface. See here, there is a metal surface. No, yes, on this metal surface so many number of electrons will be there. Now on this, let us imagine a energy falls on this, means light falls on this having some particular energy. Then this electrons to be eject out, some required minimum amount of energy is to be falls on this surface. That the minimum amount of energy is called as work function, or we can say amount of work done to remove an electron from the metal surface is called as work function. Important point you need to remember. And this work function formula is H into F naught. Here F naught is threshold frequency, or else it can be written as Hc by lambda naught, threshold wavelength. Okay, each and every point need to be remember, Nana, whatever I am discussing. Okay, clear? Okay, so work function value I have taken. Next, what they have given? They have given that work function of a substance is 4 electron volt. Okay, the longest wavelength of light that can cause photoelectron emission from this substance approximately longest wavelength what? Okay, just now I have given that work function is equal to H into threshold frequency, or else Hc by lambda naught. Yes, here this threshold frequency should be minimum or wavelength should be maximum. That means work function can be written as Hc by lambda naught, maximum wavelength it is. Okay, so lambda naught can be written as Hc by work function. Clear? Yes. Okay, H into C, just now I have told you that H and C if you multiply it will comes out to be 12,400 in electron volt when you take lambda in angstrom. But see, options are in nanometers. So for that, you need to take 1240 only. Then this lambda comes out to be in nanometers. Important point now. Clear? Bond work function given 4 electron volt is 4 electron volt, right? Electron volt cancel. So you get lambda naught in nanometers is equal to 1240 upon 4. Yes, calculate. 4 ones are 4 threes are 12. Clear? Yes, 4 ones are 4, 0 is there. Yes, 310 in nanometers. Yes, 310 in nanometers. Students understood? No? Clear? Okay, na? 25 students are there. Next, so 25 is over. Next, sorry, 6th one is over. Next, 7th one, let us go to 7th one. Photoelectric effect takes place in an element A. There is one element, on that element photoelectric effect is taking place. Okay, its work function is, element A is given, its work function is given, that is 2.5 electron volt. That means to remove an electron from metal A, we need to give this much energy, 2.5 electron volt of energy we need to give. Okay, next, and threshold wavelength is lambda, and for this threshold wavelength is given, that is equal to lambda. Okay, perfect, no problem. Next, another element B also they have mentioned. B element also they have mentioned having work function. Work function of this B element is 5 electron volt. Then found out maximum wavelength that can be produced photoelectric effect. Then what is the threshold wavelength for that? They are asking for B element lambda naught dash. Let us take. Okay. Yes. See, I have written work function is equal to Hc by lambda. Means how they are? Work function and wavelength, they are inversely proportional. Means if work function increases, wavelength should decrease. Direct inversely proportionality. See here, work function is how much it is increasing? It is double. 2.5 become 5, means it is double. Then wavelength should become half. Are you understanding? Yes. So 1 by 2. If you want, I'll go calculation methods. Okay, yeah, calculation. This you consider lambda 1. This you consider lambda 2. Okay, this is B, this is A. No, I'll write. This is work function of A, work function of B. This is B, this is A given. Okay. Yes. Here work function is inversely proportional to lambda. Means WA by WB can be written as lambda B upon lambda A. Correct? Yes. Because it is inversely proportional. That implies work function of A is given as 2.5 electron volt. Work function of B is given 5 electron volt is equal to lambda B by lambda A is given lambda. Clear? Yes. So 2.5 ones are 2.5 twos. So lambda B comes out to be, lambda will go that side. Lambda divided by 2. Yes. Perfect. Got it, students? Understanding, no? Seventh answer is A. Finished. Next, let us go to eighth one. When light of wavelength less than 6000 angstrom is incident on a metal, electrons are emitted. Okay? The approximate work function of the metal. Simple work function. Let's see by lambda, and lambda is given in angstrom, so it will be 12,400 electron volt by lambda in angstrom. Lambda in angstrom is 6000 given. Okay, two zeros cancel. It will be 124 divided by 60 in electron volt. Still it will be 12.4 by 6 electron volt because of the zero. Now 6 2s are 12.4 is there. Okay, 6 divides 4, 0.40 is there. 6 6 are 36. Okay, again 6 will come electron volt. So it is approximately equal to 2 electron volt. Yes, here option 2 is there. So they have given approximately equal to 2 electron volt. Correct? It cannot be 3 because 2.0 is there, and option also 3 is not there. However, so option 2 is right answer. Got it? So eighth one is over. Next, let us go to ninth question. Ninth question, Nana. Yes. So ninth question, what they have asked. The surface of sodium is illuminated by light of 6000 angstrom. Okay. Work function of sodium is 1.6 electron volt. Okay. The minimum kinetic energy of emitted electron is, see here, point. They are asking minimum kinetic energy, not maximum kinetic energy. Minimum, how much kinetic energy will be there? Minimum kinetic energy. Important. Yeah. So wavelength of light, how much, Nana? Wavelength of light, lambda is equal to 6000 angstrom given. And work function, how much given, Nana? Work function is 1.6 electron volt. Okay. They're asking kinetic energy. We know according to Einstein photoelectric equation, kinetic energy is equal to hc by lambda minus work function. Clear? Yes, this hc by lambda, because it is in angstrom, it can be given as 12,400 electron volt upon lambda value 6000 minus work function is 1.6 electron volt given. Clear? Yes, two zeros cancel. Just now we calculated it is about 2.0166 electron volt. Just now we have calculated in 8th question. Okay, that's why I'm writing minus 1.6. If you do this, how much you will get? 2.0166 1.600 means 0.4 means approximately 0.4 electron volt you are getting. Okay, option only not there here, so students will get confusion. But reason, see here, this is the what? This is the kinetic energy maximum it will be emitted is this much. Maximum only this much, 0.4 electron volt. Then what would be the minimum value? Minimum value is 0. Remember always, without doing calculations, we can give answer orally. Because they are asking minimum kinetic energy. So minimum kinetic energy of any photoelectric electron is 0 always. Maximum kinetic energy can be calculated by this formula. Remember this point, Nana, students. Are you understanding what I am saying? Point is important. So blindly, if say for suppose if this option is there, then you will take that option. It is wrong. If this option is there among 2, 3, 4, this option is there, then you will take that option blindly. It is wrong because this kinetic energy is maximum kinetic energy according to formula. See, read Einstein photoelectric equation. According to Einstein photoelectric effect, maximum kinetic energy of photo emitted electron is given as the in statement. Maximum kinetic energy it is. It is not a minimum kinetic energy. Okay? Yeah. I hope you understand clearly. Next question number 10. 10, yes. Yes, see there mentioned the maximum kinetic energy of photo emitted electron from surface of photons of energy 6 electron volt, falls on it is 4 electron volt. Then what is the stopping potential? Read question carefully. Maximum kinetic energy of photoelectrons emitted from a surface of photoelectron 6 electron volt is 4 electron volt, means kinetic energy maximum is 4 electron volt. Nana. Are you understanding? That means on the surface photons are falling. These photons are having energy that is 6 electron volt. In these photons, kinetic energy, maximum kinetic energy of the photon is 4 electron volts, they are saying. Are you understanding? See, maximum kinetic energy of photoelectrons emitted from a surface when photons of energy 6 electron volts falls, means these photons of energy 6 electrons volts are falling. So due to that, electrons are emitting out. This electron maximum kinetic energy is 4 electron volt. Then what is the stopping potential? Do you know stopping potential? Stopping potential is equal to kinetic energy. Do you know? Yes. How? So that photoelectric effect experiment you need to remember. See, what is a photoelectric effect experiment? Nana? Experiment is here. Open window will be there to allow incident light. Here one cathode will be there. Here one anode will be there. No? Yes. Do you remember this? Okay. Here cathode, here anode will be there. So light falls on this. Due to that, electrons will emitted out. Clear? And here they'll keep a battery. Battery positive they'll keep here and negative they'll keep here. Okay. Yes. So due to that, this electron, because of this is positive, they will come this side. And these photoelectrons will be collected out. Here one ammeter will be there, milliammeter. We can measure the photoelectric current. Now if you reverse this battery, like this, if you reverse this battery, what will happen? See, battery is reversed like this. Then what will happen, Anna? Because it is becoming negative potential, this photoelectron, whatever the kinetic energy they are coming, this photoelectron will be stopped by doing some work done. Due to this stopping potential V naught. Got it? Did you remember that concept? Okay? Yeah. So maximum kinetic energy of photoelectrons can be given as EV naught. Okay. So but kinetic energy maximum given is to be 4 electron volt. So 4 electron volt is equal to EV naught. Then electron cancel. What is V naught value? 4 volts. Yes. That means stopping potential which is required here to stop this photoelectron is 4 volt. Yes, option 1 is right answer. If you take by mistake 6 electron volt here, you will get 6 answer. It is wrong. 6 is not the maximum kinetic energy. 6 electron volt is the incident light energy. 4 electron volt is the kinetic energy of emitted electrons. Are you understanding, students, what I am saying? Clear? Yeah. So 4 electron volt is the answer here. You need to be very careful while doing this type of questions. Okay? Next. Question number 10 over. Question number 11. What they have given? See, question number 11. They have asked when a point source of monochromatic light, monochromatic means what? What is a monochromatic light? Single frequency or single wavelength. You need to remember, wave optics we have discussed that. Okay? When a point source of monochromatic light is at a distance of 0.2 meter from photoelectric cell, okay, the cutoff voltage and saturation current are 0.6 volt and 1.8 milliampere respectively. If the same source is placed 0.6 meter away, means distance if you increase 0.2 to 0.6, then what happened to photoelectric cell? Away from photoelectric cell, then what happened to stopping potential? They are asking. See, stopping potential depends on kinetic energy only. It does not depends upon the what? Does not depends upon the distance. So stopping potential remains same. First stopping potential was 0.6. So stopping potential should be same. Is option 2. It should not be 0.2. Stopping potential depends only on the kinetic energy of emitted electrons. It does not depends upon the distance where you are keeping. Clear? So that is the reason why it is 0.6 volt. And about photoelectric current, it depends upon intensity of light only. Intensity of light only. Clear? Yes. So because this is 2 meter distance, this is 6 meter distance, we can't guess whether it is 6 milliampere or 80 milliamperes. So only second option is correct. I hope you understand it very clearly. Clear? Students, only 22 came again, 25 were there previously. So 11th is over. Next, question number. Let us go to 12th one. 12th one, what they have given. See, the maximum wavelength of light for a photoelectric effect from a metal is 200 nanometers. Maximum wavelength, lambda maximum given. How much, Nana? Lambda maximum given is 200 nanometers. Nanometer unit is to be careful. Okay. The maximum kinetic energy of photoelectrons which is emitted by radiation of wavelength 100 nanometers. Now wavelength is 100 nanometers become. Then what is the maximum kinetic energy of photoelectrons emitted? Okay. Yeah. See, the kinetic energy Ke is equal to what, Nana? Energy of incident radiation minus work function. Clear? Yes, we know this. Clear? Yeah. See here, the maximum wavelength of light of photoelectric effect from a metal is 200 nanometer. Means to have a work function, this much wavelength is required. This much wavelength is required. Means this is the threshold wavelength. 200 nanometer is the threshold wavelength. Then what is the work function of that metal, Nana? Work function of the metal can be written as Hc by lambda naught, and it will be 1240 by lambda naught in nanometer in electron volt. Are you understanding? Because given value is in nanometer, that's why I am using 1240. Yeah. So work function comes out to be 1240 upon 200 electron volt. Okay. 0, 0 cancel. 124 by 20 is nothing but 12.4 by 2, means 6.2 electron volt. So work function we got. Work function is 6.2 electron volt. Are you understanding what I am saying? So work function is 6.2 electron volt we got. Okay. Now 100 nanometer energy is falling. Means this energy, how much? Energy is equal to Hc by lambda. Again 1240 upon 100 electron volt we can get. Yes. Means it will be 12.4 electron volt. Correct? Yes. 12.4 electron volt is the energy. Now 12.4 electron volt minus work function is 6.2 electron volt. So subtract these two. How much will you get? 6.2 electron volt. Yes. Option 2 is the right answer. JEE students, remember this type of questions, and NEET students also important. Did you understand what I am saying? One more time, see. We know kinetic energy is equal to energy of incident radiation minus work function. Simple calculations I will give you. Energy of incident radiation is given as Hc by lambda. minus work function is given as hc by lambda naught, means lambda naught is the maximum wavelength is required. Okay, yes, from these two we can write hc into 1 by lambda minus 1 by lambda naught we can write if you want. Okay, yes, so hc into 1 by lambda, lambda is given 100 minus lambda naught is given 200, because lambda naught is to be more and lambda is 100. Yes, it will become hc is LCM is 200, so you get 2 minus 1 here. Yes, means hc by 200 it is in nanometers now. Clear? And in nanometer it will be 1240 electron volt upon 200. So 0 cancel. It comes out to be 6.2 electron volt. Yes, perfectly. We got. You can do like this also. Understood, Nana? Whatever the calculation you want, you can do. But calculation should be. Yes, Nana. Navami, work function should be minimum. Yes, minimum only we got no 6.2 electron volt we got no. Work function minimum when wavelength is maximum. So that's why this wavelength is maximum. Work function is minimum always. So this work function will be minimum when wavelength is maximum. So that's why lambda naught should be taken as 200. Lambda should be taken as 100. So 6.2 electron volt is the right answer. Got it, students? Understood? No? Next, question number 13. Question number 13, what they have given? See, the graph important. Graphs are important. Yeah. So this type of graphs are important. You need to remember there are 3 questions on the graphs. Okay. The stopping potential as a function of frequency of incident radiation is plotted for 2 different surfaces A and B. The graph shows the work function of A is. Okay. So this is the stopping potential. We know work function is nothing but E into stopping potential. That's it. Means if stopping potential is more, work function also more. Means among these two, which is having more work function? B is having more function and A is having less work function. Means you need to compare work function of A with B. So work function of A is greater than B is wrong. Work function of A is smaller than that of B. Yes, it is correct. Same for that of B is wrong. No comparison. We can compare. So work function of A is small than work function of B because stopping potential is more. If stopping potential is more, work function is more. Stopping potential is nothing but minimum potential required to stop the electron to remove out. Clear? Yes. Stopping potential depends upon work function, depends upon stopping potential, direct proportionality. So smaller than that of B. Option 2 is right answer. Got it? Next, question number 14. Very important question, Nana. Question number 14. So many times they have asked this for your competitive exams. Okay, what is that question? See, the slope of graph drawn between stopping potential and frequency. If you draw the graph between stopping potential and frequency, how you will get the graph? The graph comes out to be like this. Do you remember? Graph comes out to be like this. This point is F0. Okay. Okay. And the slope of this graph gives you h by e. Slope of this graph gives you h by e. Very important point. Option 2 is right answer. Option 2 is right answer. Very important point. If you multiply this slope with if you multiply with charge of the electron, you will get Planck's constant. This is how they calculated the Planck's constant. Remember this point. Okay. Next question number 15. Photoelectric effect. Einstein proved E is equal to h2. This is the point Einstein has proved. E is equal to mc square. He is not proved from this photoelectric effect. K is equal to half mv square. No, he is not proved this equation. This is also wrong. Only Einstein has proved E is equal to hU from photoelectric effect. Okay. Which one among shows particle nature of light? Particle nature of light can be shown by photoelectric effect. Interference shows wave nature. Polarization differentiate between longitudinal waves and transverse wave. Important. It will differentiate longitudinal waves and transverse waves. Interference proves wave nature of light. Photoelectric effect shows particle nature. Refraction wave nature only. Okay, so option 1 is right answer here for question number 16. Clear, students? Okay, yeah. So time up now, and today you are having exam on wave optics, subjective and objective, and exam I'll conduct at 2 o'clock. Already I have informed. Okay, yeah, all the best. Okay, bye.